All right, so let's look at this Gaussian method of getting our system, which we're writing as an augmented matrix, into reduced row echelon form. So we're stepping it up here, 3 variables, 3 equations. So let's write our augmented matrix. Okay, let's see here. Now, before I even just write them down, I'm going to look, is there an advantage to switching any rows before I start? And what I like right here is I like that 1x, and I know I want that 1 in that top left corner. So I'm going to put row 2 as actually row 1 just right out of the gate. So we're going to set up a 1, a -2, a -10, like that. Now, let's see here. I don't know if there's an advantage. Well, actually, there might be. Notice that this one down here has a 0 in the y position. So I'm going to try that there to see if that helps me out, because I know when I'm done I want that to be a 0. So that might not stay a 0. We're just going to have to see what happens. And let's put this here. Okay, so we've got the 1 in the top left like we wanted. Our goal now is to make both of these zeros. So how am I going to do that? Well, I'm going to make this one a 0 by taking row 1 times -2 plus row 2. So I'm going to make a note here. New row 2 equals -2 times row 1 plus row 2. So our top row is going to stay the same. And now let's see what we get for our new row 2. So take -2 times this plus that gives me the 0 that I want. -2 times -2 is 4. What did I write here? I wrote a -y. What is that supposed to be? That's supposed to be a -1 for -1y. You should not have any letters in your matrices. All right, so we've taken -2 times -2, which is 4. 4 plus -1 is 3. We're going to take -2 times -10, which is, my goodness, I put variables in here all over the place. I apologize. There we go. We're going to take -2 times -10, which is 20, plus 4 is 24. -6 times -2 is 12, plus -3 is 9. Okay. Now, while we're at it, instead of just writing a full nother matrices, just doing that one step, let's get a new row 3 while we're at it. Our new row 3, well, we need this to be a 0. How am I going to get that to be a 0? Let's take -3 times row 1 plus row 3. So -3 times 1 plus 3 is 0. -3 times -2 plus 0 is 6. -3 times -10 is 30, plus 4 is 34. -6 times -3 is 18, plus 7 is 25. So I can do more than one operation here at a time. All right, so we've got the 1 and the zeros. Now the next spot we're going to go to is on this diagonal, and we're going to make that a 1. And we can make that a 1 by dividing everything here by 3, or multiplying by 1/3. So our new row 2 is just going to be 1/3 of the old row 2. Let's see if I can slide this up a little bit to make this work. Squeeze it in there. All right, so we've got 1, -2, -10, -6. 0 times 1/3 is 0. 3 times 1/3 is 1. 24 times 1/3 is 8. 9 times 1/3 is 3. And then we will just keep this one the same for now. There we go. All right, so what's my next position? My next position is to make this spot a 0. So our new row 3, how are we going to make that a 0? Well, I see two options. I see we can multiply row 1 by 3 and add it there. However, if I multiply row 1 by 3 and add it to row 3, that makes that a 0. However, 1 times 3 is 3. 3 plus 0 is a 3. That changes that back to not being 0. So I don't want to do that option. The better option is to take negative 6 times row 2 plus row 3. Top two rows are going to stay the same. All right, negative 6 times row 2 plus row 3. Negative 6 times 0 plus 0 is 0. I like that. Negative 6 times 1 plus 6 is 0. Negative 6 times 8 plus 34. I just don't want to goof this up here. Negative 6 times 8 plus 34 is negative 14. Negative 6 times 3 plus 25 is 7. Okay, one more step to get it into our row echelon form is we need to make this now a 1. And how are we going to do that? Our new row 3 is just going to be negative 1/14 times row 3. Zero times negative 1/14 is 0. 0 times negative 1/14 is 0. Negative 14 times negative 1/14 is 1. 7 times negative 1/14 is negative 1/2. And there we go. We've got it into row echelon form. So what does this tell us? From this, it tells us z, okay, because we've got 1z, 0x plus 0y plus 1z equals negative 1/2. Now that we have that, okay, let's use that into the back substitute it into this equation. So this equation is, I'll just kind of create some more space over here. We've got 0x plus 1y plus 8z equals 3. So when we substitute in the negative 1/2 that we now have for z, we should be able to get y. See, that's negative 4. So when we add the 4 over, we get y is 7. Now we go to the top equation, which is 1x minus 2y minus 10z equals negative 6. And back substituting that in would look like that. So that's a minus 14. This is a plus 5, which is a 6. That is a minus 9. So when we add 9 on both sides, we get x equals 15. So right there is the solution to our system. All right, let's look at one more. Let's see here. Is there an advantage to putting anything in particular into our row 1 spot? Oh boy, I don't think so. We don't have any 1 on the x's. None of these are really that easily divisible. I'm just going to lean maybe towards this one. Let's go 2, negative 1, 1, negative 1 in our row 1. Let's put this one into row 2, 3, negative 4, negative 1, 6, and then 4, negative 7, negative 3, 13. There we go. That time I remember not to put any variables in there. Okay, so we will need to create this one up here first. So we're going to take row 1. So new row 1 is just going to be 1/2 times row 1. That would make that a 1, a negative 1/2, a 1/2, and a negative 1/2. Everything else is going to stay the same. All right, next spot we're going for. We need to make this 3 a 0. So how are we going to make that 3 a 0? Well, let's take negative 3 times row 1 plus row 2. New row 2, negative 3 times row 1 plus row 2. Top row staying the same. Second row, negative 3 times 1 plus 3 is 0. Negative 3 times negative 1/2 is 3/2 plus negative 4. I just don't want to goof up any of this here for you guys in this video. So we're taking negative 3 times negative 1/2 plus negative 4 is negative 5/2. Now we're going to go to the next spot. We're going to go negative 3 times 1/2 plus negative 1. That is negative 5/2 as well. And then we are going to take negative 3 times negative 1/2 plus 6. That is 15 over 2. All right. Okay. Now we're going to make this next spot a 0, our new row 3. And how are we going to do that? Let's take negative 4 times row 1 plus row 3. Negative 4 times 1 plus 4 is 0. Negative 4 times negative 1/2 plus negative 7 is negative 5. Negative 4 times 1/2 plus negative 3 is negative 5. Negative 4 times negative 1/2 plus 13 is 15. All right, looks pretty good. Let's move this matrix to a new page. All right, next spot I want to get is I want this spot right there to be a 1. Now, how am I going to make that a 1? Our new row 2 is going to be, well, we'll just multiply by the reciprocal, negative 2/5 times row 2. All right, so that would be 0. Negative 5/2 times negative 2/5 is 1. Negative 5/2 times 2/5 is 1. 15/2 times negative 2/5 is negative 3. All right. Okay. Now, let's get row 3. We want this right there to be a 0. Okay, so how are we going to make that a 0? We're going to take our new row 3. I'll just keep that in orange. To be, let's take, what do we want here? 5 times row 2 plus row 3. So 0 times 5 plus 0 is 0. 1 times 5 is 5 plus negative 5 is 0. 1 times 5 is 5 plus negative 5 is 0. Negative 3 times 5 is negative 15, plus 15 is 0. And something interesting happens here. I only have 1 minute to explain it. We didn't end up with just a 0 there and a 1 there. We have zeros across the board. What does that bottom equation tell us? 0x plus 0y plus 0z equals 0. In other words, 0 equals 0. Okay. And what does that mean for us? If 0 equals 0, is that true? Is that always true? Yes, it is. For this one, there are infinitely many solutions. Okay. So that can still happen, right? We have more than one possibility when we solve systems. Okay, we can have infinitely many solutions. We can have no solutions along with our exact solution. So keep that in mind as you solve these. So there we go. That's our Gaussian method of trying to get it into row echelon form. Thanks for watching.